We've got a whole stack for helping software developers out, helping product managers and the infrastructure like Kubernetes and platform as a service things that it runs on. We've got a great set of tools to do your build pipelines, your CI/CD, or your secure software supply chain. There's so many names for this kind of thing nowadays that you can pick and choose whatever you want to talk about. And then finally, going along with a lot of what you'll see today, we have a lot of consultative services and other things to help you change over the way your organization does software development, to have it be more product oriented, and also how your operations people can do more DevOps related and site reliability engineer related stuff. But anyhow, if you're interested in that, you can go to tanzu.vmware.com/developer, which I'm sure everyone will remind you of. And it's the place that we're collecting together all of the developer and operations related things. So just briefly, and I'll come back and remind you of this before we go into the workshops, but I want to go over the logistics of what we're doing. So first, we're going to have an opening talk from Olga and Marcin. They always give a nice tag teaming talk, and they're going to go over lots of the great integrations and features that we have in Spring and Kubernetes to kind of make them work tightly together, to give you a sense of what it looks like to do modern application development with that. Then there's a couple of workshop tracks going over more in depth on those same topics. And you can have a lot of one-to-one interactions and Q&A with the instructors there. You can have live Q&A with them. And that'll be how you can spend the rest of your day. And of course, you'll be able to get the code and do all of that. And just so you know, when you're done with your workshops, you can feel free to leave. You don't have to stick around for any reason. Wait for a bell to release you like that. And we'll put some links in the chat for where you can find those things out. And then finally, before we get to the talks, again, if you're interested in this kind of format and learning and even asking questions online, we nowadays broadcast a tremendous amount of things like this several times a week, almost daily, over at tanzu.tv. And you can find links to that again at that development center at tanzu.vmware.com/developer. And we might have another spring tour coming up, but if you want to see a larger event of this, we have our big conference, SpringOne, coming up on September 1st and 2nd. I've been looking through all the talks in the track that I help out with, and there's some great overviews and case studies and tactics of organizations improving the way that they do software. So all of that, hopefully you didn't feel the need to take notes on it, but all of that will be summarized in a follow-up email along with all sorts of other stuff we have. So with those logistics taken care of, I want to just briefly introduce Marcin and Olga. This is always a really nice talk to see how all those wacky Kubernetes things you've been hearing about, container style development, how they fit together well with doing a Spring Boot application. So you finally get a sense of what it looks like and how you might be using it day to day, not just the wonderful, magnificent benefits that you get from those things, but the actual hands-on keyboard and mouse stuff that you'll be doing. So with that, I'll let them take it away, and I'll come back in a little bit to send you off to your lovely workshops. Thanks.
Hi, so thank you so much for joining today's workshops. We will start off with Olga, I guess, sharing the presentation. Olga. Okay, can everybody hear me?
Okay, can you hear
now
me
we
now?
can hear you, yes.
Okay,
yes.
awesome. I'm going to share
Fedora
the screen.
again, right?
I don't think that's the issue. Anyway, so just give me a moment to share my screen. Okay, so thank you all for coming and welcome to our talk about the new things and software development and about how the Spring team is, what the Spring team is doing to stay on top of these things and make the development of applications using the new trends easy. So here's our agenda. We are going to talk a bit about how systems have changed over the past few years. and then about how our team is providing tools and ways of developing to make it easy to seamlessly integrate with these new trends in your applications. And at the end, there will be a Q&A. So over the past, I'd say, decade, we have seen a lot of movement from these big, humongous monoliths to smaller, more distributed systems. So we all know that a lot of us have ended up splitting our monoliths, or at least starting the new systems as microservice environments. And of course, as we create many instances of the same service, we have started also to have a very complex distributed architecture with cloud architecture patterns, architecture where we rely very strongly on network connections. And another thing that has happened was the start of serverless. So now often we only want to run a function on a cloud provider, so let's say Lambda. So we run a function and we expect it to start very fast, already have instance peak performance, do its job, consume little RAM, and then shut down once the job is done. So for that scenario, it is very important to have the quick startup, but also is extremely important to have low memory footprint, because RAM memory is extremely costly in the cloud. So we don't want to be paying for that. And of course, instant peak performance, because we want to do whatever we are executing very fast. We cannot wait for it to sort of warm up and then gain performance. Also, we need our applications to be extremely scalable, because if we want to have so many instances of so many services, then we need to be able to quickly spawn new instances. And also, we want our systems to be very resilient. So now, a lot of time, depending on your use case, but there are much more use cases than before, when what is really important for you will be availability and not consistency. So of course, it's good to have some kind of consistency at the end, but there are a lot of services where availability and resilience is going to be the most important for you or for a business that is creating the product. So we need to have a very resilient system, and it's not that easy to manage in a resilient way, that big fleet of instances for each service and make everything scalable. That's why we are relying more and more on platforms such as Kubernetes, and also on infrastructure as a service, to just put some of this burden on somebody that specializes in it, and then the developers can do their work easier. Also, as this scenario has changed and we have this big distributed system, we cannot just rely on grabbing our logs on a single server anymore. It just won't do. So we need to start having new tools and using patterns that will allow us to understand what our system is doing as a whole, in order to track each operation throughout the entire system, and in order to be able to reason about it. Because it's not going to be doable, or at least not going to be doable in some reasonable time, if we're just going to go through the logs on every instance. So we need a better way of dealing with it. And in the Spring team, we always want to, first of all, respond to the important things that are happening and make new ways of developing easier for developers, and also then be at the front of these changes and introduce new patterns and make it very seamless for the developers to work with all these new paradigms. So we will be talking about some of our integrations or some of our support frameworks that we have for these new trends to make the development in this new environment easy. The first thing we are going to talk about when it comes to this is Spring Native. So Spring Native is a project that provides support for native images. And as of yesterday, version 0.10.0 was released. and it is still in experimental org. However, the team is working very strongly on this project, and we want to make it we are making it our priority to provide first-class support for native images. So what are native images? So we based on GraalVM native images. And for those of you who don't know, GraalVM is a high-performance polyglot runtime, which was created with the thought of having one VM for all languages, increased efficiency when it comes to memory, CPU, and resources. And importantly, GraalVM offers both just-in-time compile and ahead-of-time compiling. And yeah, some people think that GraalVM offers only native images. No, they also have their own JIT. And when it comes to the just-in-time compilation and ahead-of-time compilation, what is important here is that both of them can allow us to achieve certain metrics when it comes to our performance. In the case of ahead-of-time compilation, what we will do is we will have an image that will be generated, will be built before, and can be stored and then can be run instantaneously on our machines. And also in the process of creating this image, a lot of optimizations will be introduced so that the code later consumes, our program later consumes little RAM memory. And of course, then these characteristics will be very enhanced. So the startup speed will be great. The memory footprint will be much lower, and also the packaging will be much smaller. However, there may be also scenarios where this is not what you're looking for. So this is actually a diagram from one of GraalVM's creators, and what we can see that there are scenarios such as this scenario where we want to achieve peak throughput and reduce max latency that will have the best possible values for us. And then actually just in time can be better for us because JIT will be adjusting and introducing optimizations as it's sampling the data. And there are already some tools that allow you to even work with the Aot technology and also achieve good values here, but they're, I think, mostly commercial. So if you are staying with our open source technologies, many times you will want to decide what is really the characteristic that you want to optimize in your application. And how are the native images built? So the code that can be reached for your application is going to be analyzed, and the application code will be taken into account, but also any library code, JDK, and in case of Graal, also a substrate VM code. And then after this analysis, also a pre-initialization will take place. So some preliminary configuration will already be loaded. And in order to optimize the whole process, so later when you run it, you already have preloaded initial values for your config. And the important thing here is that compilation, class loading, and preloading of configuration will take place in the build phase. And there is the closed word assumption. So no classes will be loaded at runtime. The class path is going to be fixed at build time. And also the unused parts are going to be removed at build time, which is going to also provide optimization. And to summarize, the pros would be instant startup, no JIT, which causes reduced memory footprint in terms of RAM. And the Spring Native team has some time ago calculated that it was 3 times to 5 times memory reduction. And then instant peak performance. When it comes to cons, the throughput and latency can suffer. And also we cannot forget about the build time. So this image has to be built at some point. And as a lot of other optimization work is also taking place and a lot of analysis, this build process becomes very long. So for an application which build time we could count in seconds with JIT, with AOT, we might need to count it in minutes. And this, of course, is also bringing about some possible bottlenecks in the way we release our software, let's say building it on Jenkins agents, it can take more time. So these are all the things that we need to be conscious of, and there will be some scenarios where the native images will be the best approach we can take, and some scenarios where we might want to stick with a different approach. So what is Spring doing to support native images? First of all, in order for the native image to work, you need to provide some additional configuration. So there are some things that will not work out of the box when the native images are being built. For example, reflection, proxies, and resources. For these things, you will need to have special configuration JSON files. And this is just an example of a very small piece of such a file. These files tend to be humongous. But anyway, this is the way it looks. And yes, you can create your own files, and you don't even have to do it manually because there is an agent that you can run while running your application or while running your test that will generate them for you. However, you probably wouldn't have to be responsible for doing this for libraries. You would only want to be responsible for your own application. And of course, in Spring, we heavily rely on proxies, and also there is reflection going on and access to resources. So we don't want you to have to do it on your own. We want to provide a first-class support for you. So we want to generate these files for you, and you don't need to do anything with that then. And this is a lot of work that is going on. You will see the samples in Spring native projects that reflect the projects that are already supported, where we provide this kind of configuration for you. Also, as you see, these JSON files are quite tedious to work with. So apart from pre-configuring it for your applications when you use our libraries, what the Spring native team has prepared is a native hint API, which basically allows you to write code, as what we see in the slide, that will later end up with generating these kind of JSON files. So you can use it for your own application code that requires configuration. And another nice feature that we have is that we can also specify a trigger. So here we have this enable discovery client import selector class, which will trigger the type hints that we can specify. So this is the important part of what the Spring native team is doing, but they also provide optimizations. And this is actually, these are some measurements that were taken by Spring native team and published in a presentation some time ago. So as you see, the memory time and the startup time improves incredibly. These are, by the way, measured on PetClinic app, so many of you might know this app. And build time has gone much larger. However, this is still a project that is in experimental phase, so it is expected that this value will also improve. So it will definitely be larger than what we are used to with JIT, but it should not be as large. And if you want to track what is happening when it comes to optimization, the Spring native team publishes, allows to access its build logs for the native image samples, where you can see measurements and they're built daily, probably even many times a day. Other things that we provide is some optimizations. So for example, while building the native images, if you have, let's say, conditional on class, you already know that this class is available or not there. And if it's not, already some code can be optimized and removed. And there's also additional agent support for tests. When it comes to Spring Cloud and Spring Native, there's already quite a lot of our projects, the popular projects that are supported and can be run in native images. So if you use any of the Spring Cloud projects listed here, you will not have to add your own configuration for our components. And these are the projects that are in the roadmap. Okay, we will also now do a quick demo. So let me go to the IDE. Okay, first of all, I have a Eureka server app that is running. It's a normal, usual, traditional app. And then I have this native client that uses Spring Cloud Eureka client, and is a very simple boot application. And what is important here is that we will have our Netflix Eureka client dependency, which will allow to auto-configure and connect to the Eureka server. And then we will have something specific to Spring Native. And the good thing is that this is already supported at start.spring.io. So you will be able to generate your project already with this native setup. And the first one that we have is Spring Native dependency. This is the one that we see here. And this will give us the mandatory classes needed to run Spring with native images, and also the configuration API that we have just seen. Then we have also Spring Aot Plugin. And this Aot Plugin actually improves native image compatibility and also footprint. And this is the one that automatically generates configuration files. And then we also have a GREL VM plugin that you can see here. And just a word of clarification, if you generate this project on your own on start.spring.io, you will have this build packs support for Docker images. So that's also a possible way to run it. Since I want to run it with GRAL on my machine, I have changed it and I have commented that out and added this here. So what you need to keep in mind while adding the GRAL native plugin is that both the Spring Boot Maven plugin and the native image Maven plugin from GRAL take place during the package phase. So in order to avoid a clash, we are adding a classifier. By the way, if this is a bit fast, don't worry, we will share all the code so you can go through it calmly in your own time as well. And then another thing that is of interest here is we are adding build arguments, because again, in order to optimize and make the images smaller, a lot of things are removed by GRAL. So for example, if you don't specify that you want to use HTTP or HTTPS in your application, the necessary classes will not be added. So yeah, you need to have a look, because there will be more things for which you will need your own, to add your own arguments. Okay, so how do we use it? First of all, we need to have GRAL on our machine, so the GRAL Java SDK, and we can use it using SDK man, which is a SDK manager. So that's what I'm going to do here. And then you need to remember to install the native image support with this command. And now what we would do usually is to run Maven package. And I have here a profile native image. That's because all the setup that I've just shown is taking place in a profile. If you don't want the profile, obviously you can have this in the main part of your POM. And as you see, we just run Maven package and nothing else. And what we will end up with is going to be the image. So I'm not going to be running this now because it takes minutes, but instead what I'm going to show you is this log. So we will get this kind of summary each time we run it, and we'll be able to see how much time it has taken. So as we see, it has been minutes. So I don't want to be running it there, but you have the log, and here we have the image saved in target. So as it is in target, we can just run it this way using the command. And what is important here is that I'm setting the XMN because GRAL also has memory management. And actually by adjusting these parameters, you can gain a lot when it comes to memory usage. So we can run this up, and this is usual normal Eureka client. Will be able to do some calls later on. However, what you need to keep in mind is that even though this has started super fast, you need to think about your whole architecture, because, for example, it will take some time to connect to Eureka and get set up there. So if I run it just straight after starting it and I do some calls, I might not get any reasonable responses. Let's see. Okay, so it's already there, but if I ran it straight after running the native app, I would still have to wait a bit to connect to the server. And just to give you some idea about the size and the startup. So this application, when I was running it, normally without native image, was taking about 2.7 seconds to start and was using 185.3 mega memory RAM roughly on my machine. And now it's starting in 0.326 seconds and is using, well, it was without the XMN setup, it was using 80.5 mega, but with the XMN reduced, it is using 11.7. Of course, these are not some great performance tests. This is just what happens on my machine, but you can see the scale of improvement. Okay, so that's it. I'm going to stop sharing and Marcin will take us to the Kubernetes part.
Thank you, Olga. So let me share my screen now. And let me move this away. And one more thing. Correct. Okay. So thank you, Olga. And now let's talk about how Spring loves case, because Olga mentioned the native part, but what about Kubernetes, right? We are all into Kubernetes. So let us see if there's a good way in which Spring supports Kubernetes. So on the agenda, we're going to mention Spring Boot and case, what's new and noteworthy for that matter. And then we'll try to answer the question, what is Spring Cloud Kubernetes and when to not use it or use it? So the problem we're trying to solve, the initial one, is we often might have this need to read certain config values the platform supplies. And we can think that, okay, one way to do this is to inject those configuration values via environment variables. And that's a good idea. However, what if the value is supposed to be kept secret? If it's an environment variable, that's not really the case. So the solution to the problem is that currently many cloud platforms allow you to map those configuration values into mounted data volumes. For example, in Kubernetes, you can in volume mount both config maps and secrets, right? So you don't have to pass them as environment variables, you can mount them as volumes. And there are two common volume mount patterns that you can use. One is that you have all the configuration in a single set of properties. And usually those are written as YAML, or the properties are, let's say, set in multiple files, and they are written in a directory tree. And then a file name is actually a key, and its contents are the value. So let's talk about the first case, so single file containing complete set of properties. So with the latest releases of Spring Boot, we allow you to change the way the configuration should be read, right, via the Spring config import property. So if you have a single file that contains all the configuration, you should just point to that location. What if we have multiple files in a directory tree? You can use the config tree prefix, and that way you expose all the files as properties. So let us now assume the following Kubernetes configuration tree. So we have etc config, my app, and then we have two files, username and password, which means that the username is the key and password is the key, and the contents of those values are the values, the contents of those files are the values for those keys. So in order to read those this configuration tree, we can pass the following property: Spring config import, optional config tree etc config. So we're saying config tree etc config, meaning there's a configuration tree of files starting at etc config. Why do we need optional? Because if you don't set it and you run your test will not work, assuming that you don't have such a etc config folder. So optional means do not break if the file is not there. Another problem here we might face is how to store multiple configurations in a single configuration file. And how can we store configuration that is platform specific? So the solution is that Spring Boot allows you to have a single file, physical file, split into multiple logical documents. And then those documents are processed from top to bottom, and the later documents can override the properties defined in the previous ones. I mean, YAML is the solution to everything, but let's say here it's one of the solutions. So if you have, let's say, application YAML file, or like any YAML file, so YAML supports multi-document syntax out of the box. So in order to do that, let's say you have a Spring application named my app, and then you provide 3 hyphens, and that means that the earlier document has finished. And then you have the second document where you say, hey, the following section should be applied only if you're running Kubernetes. So if I run this app on my local machine, its name would be my app. If I run it in Kubernetes, the name would be my cloud app because it overrides the previous one. If you're using properties, then there's a problem because the properties files do not have such an inbuilt mechanism. However, we assume that if you have a comment with 3 hyphens, that means that we are splitting this, let's say, physical properties file into multiple logical ones. Another problem we are facing is that Kubernetes requires you to have the liveness and readiness probes. How do we support that in Spring Boot? So before we go to that, let's define what liveness and readiness is. So liveness state means, or asks the questions. Internal state allows it to work correctly and can recover by itself if it's currently failing, right? So the questions that the liveness state answers. So if the answers are wrong, so the liveness is broken, it means that the app cannot recover from the problem and the infrastructure should restart the app. And now you can say, oh, okay, so liveness is essentially a health check. Absolutely not. And why is it the case? Because the liveness state should not be based on an external check. Imagine that you have 50 apps and all of them are depending on a database and the database is failing. That means that we would have a massive restart and cascading failures across the platform if you rely on a health check. What about readiness? So that means that the application is ready to handle traffic. This is the case of readiness. So a failing readiness state means that the platform should not route the traffic to the application for now. And that typically happens during startup when the command line runner and application runner are being processed, or at any point in time where the app decides that it's too busy to handle additional traffic. And once the application runner and command line runner have been called, we can assume that the app is ready to handle the traffic. So what about the Kubernetes probes? How do we support them? So we do support out of the box the application availability state. So if you deploy to Kubernetes, we have the concept of actuator endpoints. And in Kubernetes, you get the liveness and readiness information in the dedicated health indicators. And they are there under the global health endpoint group. So you have actuator health liveness and actuator health readiness coming out of the box via Spring Boot in Kubernetes. So then you can configure your Kubernetes infrastructure with the following endpoint information. So you have the readiness probe and liveness probe, and via the HTTP GET section, you can provide links to the actuator health liveness and actuator health readiness. And of course, additional configuration can be applied. So another problem we can face is like we are in this era of doing, let's say, cloud native apps that we don't create, or we shouldn't, or you should reconsider doing the Docker setup ourselves. There are, let's say, mechanisms far better suited to which we can delegate this problem. And that mechanism is called the build pack. So the idea is to transform your app source code to images that can run on any cloud. And there is an implementation of the cloud native build packs called Paketo build packs that provide this language runtime support for apps. And they can make the image building easy, performant, and secure. So how does it work? So Spring Boot comes with a Maven plugin and a Gradle plugin, of course, that allows you to do the Docker build. So you just call Spring Boot build image. So the Docker build starts, then the Paketo build pack logs can be seen. So proper base images are being downloaded, and the best part is applied over here, which means a runtime analysis and layer applying. So depending on what source code you have, proper layers will be applied. And off to Olga, and Olga's going to talk a little bit about Spring Cloud and K8s.
Yeah, so that's the project that many people have heard about, some have used, many ask us about that. Do you now still need to use this project if you want to use Kubernetes with your apps? So to summarize, Kubernetes provides cloud-native patterns that are handled on platform level, while Spring Cloud provides cloud-native pattern handled on application level. And in order to integrate the two approaches, some time ago, Spring Cloud Kubernetes project was created that allows you to use these Spring Cloud application level abstractions also for your applications which are running on Kubernetes. Now, this was done quite a long time ago before there was much other support in Spring for Kubernetes. Now, the situation has changed, and as we see, as Marcin has shown you, you actually do not need to use Spring Cloud Kubernetes to use Kubernetes with Spring. And a lot of times you will choose to use Spring Boot directly with Kubernetes, and it will be the most useful approach, specifically when you are creating new apps from scratch and when you are running your entire microservice ecosystem on Kubernetes. It is going to be usually the best approach for you. And when is Spring Cloud Kubernetes most useful for you? So first of all, if you have an application or an ecosystem that is already running using Spring Cloud and is running on some different platform on cloud, and you want to move it to Kubernetes, it is going to be easy for you if you just use Spring Cloud Kubernetes for your migration. Then if you are running application across multiple platforms, you might find it useful for you to have one single abstraction that you will use on top of all these platforms, and you cannot then assume that you will only stick to the Kubernetes components if you have your applications within the same system running also on different platforms. And another thing that is something that actually we have heard from our users and also users from big companies, that they like the transparency for configuration options on developer level that Spring Cloud Kubernetes offers, for example, when it comes to setting up load balancing from developers' point of view. And another use case, which is something that we very much recommend if you're interested in it, if you are creating your own Kubernetes controllers in Java, Spring Cloud Kubernetes provides you building blocks to do just that. So to write Kubernetes controllers and write them in Java. The downside of using Spring Cloud Kubernetes, and why we also often recommend using it differently for the new apps, is that it uses Kubernetes API servers. So your apps will need permissions, appropriate permissions to interact with it. And this might not always be what you want to do, depending on the purpose and the security level of your app. And other than allowing you and giving you an API to create your own Kubernetes controllers, Spring Cloud team has also created our Kubernetes controllers that we make available for you. So the one that is ready is Spring Cloud Configuration Watcher, which recreates the refresh capacities of Spring Cloud config in a Kubernetes environment, working with Kubernetes config map, config max, and secret volumes. And it also supports both HTTP refresh from Actuator and Spring Cloud Bus. And I've added the links for you to see how it works and read more about it. And there are also some other ones in the roadmap, specifically the one for service discovery. And now we will go to a demo.
Yeah, I think we're going to skip the demo because we have 5 minutes left. So yeah, so I'm going to go directly to debugging and optimizing complex distributed systems.
But the slides have a link to a very similar demo to what we wanted to do, where you can go through step-by-step a workshop, and we will link it for you so you can do it on your own.
Same case, I think at the end of this part of debugging and optimizing complex distributed systems, there was supposed to be a demo, but I don't think I'm going to have time to do it. But the majority of that demo is actually inside the slides, so don't worry. Okay, so let us imagine that we have the following system that consists of 4 services, service 1 calling 2, and 2 is calling 3 and 4. I think that resembles, let's say, the vast majority of your systems, right? Truth be told, it doesn't look like this. It looks more like this. So you have a lot of servers on which those apps are deployed. But still, I'm lying because it's not a single instance. It's a lot of instances deployed to many physical servers. So one way to find errors is, for instance, SSHing to each of those machines and grepping for errors. That could have been done a decade ago when you had, say, one instance of each of your apps. However, right now with the, let's say, microservices and having a lot of instances, that might be a problem. I mean, we have the banded screens, but still, it can be problematic to actually tell and grab the logs like this. So what we can do is change this approach a little bit. However, the critical thing about observability is to have the apps answer 2 main questions. One, can the apps actually produce metrics about their state and publish them? And the second, is there a way to actually correlate the logs? So let's try to address the metrics problem first. So what if each of the apps had an inbuilt mechanism that allows the application to produce the metrics about itself? If that's the case, a given metrics store could either pull for the metrics or the metrics can be pushed to the metrics store. Whatever you choose, then the visibility changes. It's the graph of applications is getting dynamic, which means that you can click on a given service and verify what's the error rate, what's the 95th percentile, etc. You can have a nice dashboard showing you the number of requests per second, number of errors, top requests, and the request latency. And here you can see that for some reason, we have the 95th percentile is equal to 51 years, which is not the best result. So metrics was easy. What about the log correlation? Let us imagine the case again that we have those 4 services and the first request comes in and we would like to attach some sort of an identifier. Let's call it a trace ID. It can also be known as correlation ID. So this ID, we would love to be attached to every single log statement, propagated over the wire, and added to every single log statement, regardless of where the app is being actually run. I mean, regardless of which service it is, let's say, which service is logging the information, right? Great. So if we have such information, we could push this those logs to some sort of a file or system out, whatever. And one way of doing, let's say, searching for all the logs corresponding to this particular correlation ID or trace ID is to, again, do the tail with grep. But we know that it doesn't scale. So there has to be a better way, and there is. So we can push the logs to a log store or pull for the logs by the log store. And then if we have such a stack trace, such a log statement, you can see at the top left that there is some sort of an identifier, right, attached to it, this trace ID. And then using your favorite log aggregation tool, here we have an example of an Elk Stack, which means Elasticsearch log/Kibana. We can search for all the logs that have the given trace ID set there. And that way we can chronologically order the logs and verify what happened in time. But what if the system is slow? Because when we have an error, that's pretty easy. But what about the case where the system is slow? So let's look into service 2. Service 1 is calling service 2. Inside service 2, we have an application controller and application service. So request comes in, and then for application service, calls service 3 and calls service 4. So here we have an operation of some sort, service 1 calling service 2. Maybe here we have another one. So maybe the application service, we would like to, let's say, calculate the time required to do this work over here. Maybe this is important to us. And then we have two additional operations, one calling service 3 and one calling service 4. So if that's the case, for every single operation, not only do we want to propagate this correlation ID to trace ID, we want to also create a new identifier. And instead of calling it an operation, we will call it a span. So here we have the first span. Then when service 1 is calling service 2, we have another span. When service 2 is calling service 3, we have yet another span. And finally, we have a span for making service 2 call service 4. Why does it make sense? Because a span has additional information. It knows who its parent was. That way we can create a tree-like structure. We know when it started, we know when it stopped, so we know its duration, and we can also put some additional metadata there. So is it that simple? No, because we need some sort of a framework that will handle the life cycle of a span and will propagate the tracing information over the wire or via frameworks and libraries, right? So here we can see that we decided that we need 3 spans, one for calling service 1 calls service 2, and then service 2 calls service 3, and service 2 calls service 4. So what do we do?
Hi, Martin. If you could slow down just a little bit.
Sure, no problem.
To go a little bit slower. And
okay,
if
no
the
problem.
demo, people are really excited about the demo as well. So if it's not,
I can do the demo. It's not a problem.
Yeah, if it's not too long, it's okay.
No, it's extremely fast. Okay, sorry. I will slow down. So coming back to the case, we have those spans. And what can we do with the spans, right? We can send them out to the span store. So like we had it previously, so we had metrics and we're sending out metrics to the metric store. We can send logs to the log store. We can send spans to the span store. And why does it make sense? Because then we can sketch the graph, the production dependency graph. That means that we have this happened already, right? If we have a tool like the one that we see here, we can see what happened actually on production. That means that indeed service 1 called 2 and 2 called 3 and 4. And we have additional information because we know how much time the whole trace took. So here we can see that it took 1.3 of a second to actually go through the whole 4 services. And if we are interested in a given span, so in this case, I'm looking at a span in service 3. However, each of the bars is actually a span. So I could reason about the fact, why does it take 300 milliseconds on the service 3 side to actually process the request? And I know why, because I put a thread sleep there. But in your production systems, that may be extremely interesting to you. And that way you can reason about the latency in your system. So what are the solutions that we think are applicable here? So for metrics, I think you should consider using Project Micrometer and Spring Boot Actuator. So if you add Spring Boot Actuator, you get Micrometer out of the box. For tracing, if you add Spring Cloud Sleuth, you get the tracing solution again out of the box. You don't have to actually write any tracing related code for your apps to get traced. So the screenshots you've seen about metrics and tracing are the ones coming from VMware Tanzu Observability by Wavefront. It's an enterprise observability for multi-cloud environments. And if you're using Spring Boot apps, you can have the freemium option. So free Tanzu Observability, no sign up needed. So what I will show you right now, since I don't want to hijack too much of the time, I will not write it from scratch, but I will show you an already configured and created presentation service that will call service 1 that calls 2 and 3 and 4. I have those 4 apps already running on my local machine, connected to Wavefront and connected to Logs.io, which is the hosted version of the Elk Stack. And hopefully, if the demo gods are fine with me today, if I run the presentation service and I send the request to the presentation service, then we will go through the whole 5 apps. Okay, time for the demo. So, where's my mouse? Okay, it's here. So we have the presentation service. Let's look at how it looks like. So we have the Spring Boot starter. Since I love the YOLO approach, I will work on snapshots. So I have Spring Cloud's snapshots version of the 2020 release train. I have the Wavefront version as well, 2.1 snapshot. And what we have here is the actuator, because I want to have the metrics, right? We have the web part. We have the Wavefront Spring Boot starter. We have the Sleuth starter. So those are the main dependencies. And now, since I want to push my logs to logs.io, I have their dependency. And I also have the logs/logback encoder because I want to cut my logs into JSON files, so to say. So if I go to logback Spring, I have my custom logback configuration. And here I have the logs.io logback appender. In my environment variable, I have the token. And this is how the logs will look like, right? They will be already cut into pieces. Now, application properties. So I have the name of the app is called presentation service. And now in Wavefront, we have this notion of a service, which corresponds to actually a single application. So this is why I redirect the Wavefront application service value to Spring application name. And now Wavefront application is a logical application. So if in my case, I have a logical application called Sleuth documentation apps that consists of 5 other apps, all of them should be, labeled in the same way, right? That way I will say, hey, give me all the view for the Sleuth documentation apps, and I will get all the 5 apps. Of course, I have some tokens flying around in my environment variables. That way I will be able to reuse the Wavefront account that I have. Now, what about the actual code? It's extremely simple. We have a Spring Boot application, a REST template bean, and a controller. As you can see, there is no tracing code whatsoever because you don't need it. Because when you're using Spring Cloud Sleuth, we're taking care of everything. So what happens here is if you send a request to, 9876, we're going to log something out, and then we're going to concatenate the presentation service text to whatever we get via HTTP. That's it. So I'm going to remove the logs.io logback queue, and let's run the app. Of course, I need to download all the latest snapshots. I mean, what can go wrong, right? Okay, so we are almost there. We are running the app. Okay, so we're running the app. Seems okay. So now, if I call HTTP 9876, we should get presentation service, hello from service 2, 3, 4. Great. I'm going to do it a couple of times because when you're using the hosted versions of things, they tend to sample out a lot of your requests. So hopefully one of them actually gets there. And now you can see that in the logs, we have the application name, trace ID, and the span ID. So we have the trace ID automatically added. So if I copy this, and if I go to my Kibana dashboard, and I try to search for this logs, okay, that wasn't sampled. Maybe this will be. I mean, that was sampled out. Okay, so this one is fine. So here we can see that we have the presentation service, service 2, service 4, etc. And they are put in a chronological order. That way we can start reasoning about all the, let's say, cases that, all the situations that happen in our system that led to the given problem, right? If there was an exception from or something like this. And now if we go to VMware Tanzu Observability by Wavefront, if I click over here, wait a second, last 5 minutes. We should start seeing some things over here. So the documentation app, we have the presentation service. No traces found. Let me send some more requests. Maybe they got sampled out again. Hopefully we get at least one. Search. Okay, last 5 minutes again. Okay, that's unfortunate. However, I'm going to show you from the last 2 days. There you go. So this is the case where we did manage to find the presentation service within our flow of requests. So this is how we actually managed to reason about the latency. So we can see that the whole flow took 942 milliseconds. If we click over here, we can see that, for example, service 1 got a request and it returned to 100. The controller class was service 1 controller, and the HTTP path was start, right? So we have additional metadata that we can reason about in order to understand what really happened in our system. And if we go to the service view, we should see, yeah, we have some metrics of our presentation service application. We have the request latency, some JVM stats, etc. So just by adding Spring Boot actuator and the Wavefront starter, we have already started gathering metrics. Okay, so I guess this is from our side. We have some helpful resources, and the links will be provided to you if you're interested in the questions, or like the cases of Spring Native, how Spring Boot works with native, and about Spring on Kubernetes. So that's it from our side. If you have any questions, we are more than happy to answer them.
Well, thanks. That was a great talk. I think hopefully you all got the idea of how all this stuff fits together. And I think what's always nice is to know the, as Olga started off with, the foundational reasons and things that you need to achieve the marvelous benefits that we all shall live with in the future. Well, I just want to briefly go over the rest of the day. But first of all, you know, usually if you're in person, it's easier to see how much people appreciate something. And so I would encourage you, if you appreciated that talk, to just write some thanks, or maybe use some silly emoji or whatever you like in the chat window there. Olga and Marcin will appreciate it. So, you know, that would be great if you wanted to show your appreciation there. So what we have for the rest of the day are workshops, and we have 2 tracks of them. The first, they're both the same workshop, but the first set of workshop leads are Jakob and Ninad, and they'll be in room 1, and then we have Jonathan and Timo in room 2. And again, you can get the code for this and the things you need in GitHub. There'll be a link posted in the chat, and it's really a great chance to work with some very experienced people and ask them whatever questions you might have, so you can understand how all this stuff fits together and what to do. And then I just want to remind you of a couple of things. One, if you want to dig more into kind of what the Spring and also the Tanzu way of thinking about development is, all of the modern way of doing development that Olga and Marcin just talked about and that you learned this afternoon. If you go to the Tanzu Developer Center at tanzu.vmware.com/developer, you can dig around in there. You can also see a listing of all sorts of online events that we'll be having, including our large conference at SpringOne, September 1st and 2nd. And then also be sure to keep an eye out for the follow-up email that we'll have that'll have links to the recordings of this and other relevant things. But most importantly, it'll allow you to select which piece of Booternetes swag that you want. Free, cool stuff for you to relive the memories. You know, there's lots of nice sun nowadays, but eventually the rain will come back and you might need some cozy reminders of when it was good weather out there. So you should pick one. So with that, as a reminder, there's a link to everything you need for the workshops in the chat window. And obviously, to remind you again, feel free to show your appreciation to Olga and Marcin and the instructors as well. And with that, enjoy the workshop. And I appreciate y'all spending all this time. And we'll see y'all at the end. Enjoy. Bye-bye.